So fill up, split, fill up. But sometimes we can fill up this one. So capacity can be 100% depending on the order. So even though we have the same data, exactly the same data, but with a different insert sequence, it can be different level of the data. Okay, level of index. So performance can be different. So that's one thing. When you have the many index, or when you have the index, but so frequently insert, delete the data, your level of index will grow a lot. Okay? Even though you have the same data, but depending on the order of sequence or how often your data is inserted or deleted, it can be different structure. Okay? So at that time, we need to address such a problem. How? Best way is recreate. You can remove the index and create it again. It's like the compact, right? The defragmentation in Windows XP, right? Do you remember the defragmentation in Windows XP? So because your file is the sparse scattered, so you can compact. Similarly, when you have the many nodes, so you can remove index and recreate the data with optimize the sequence of the data. And that's the one thing you need to keep your mind once you join any database project. From time to time, you will encounter. So my query is working very well, very fast, the beginning of project. But a year later, you realize my query is very slow. So you complain to your database administrator, or the UM administrator, or your project manager, but nobody answered. Sometimes because of the level of index, the query optimizer is coming. This is not a good index. So skip using this one. At that time, you can ask the database administrator, why don't you recreate the index? Then it's working very well. So that's another thing you need to keep your mind. And next topic in the indexing structure is deleting the data, but I'm going to skip this part. The idea is the same as the one in the B2 index, so we can merge, but it's not straightforward as you can imagine. But it's not the perfect optimized one, so I'm going to skip. But you can understand what's the idea. We can merge it if less than a half. But the problem is each node can be merged sometimes, but so that's called the underflow. So we will skip that part. So we have seen the several index structure, but most of them will be pursue the search tree. So but search tree is going top to bottom, it's unbalanced. So to address the problem, so we have discussed about the B3 and B plus 3 index. Now you can understand. Why don't you submit why don't you shift to right? Then the full student, why don't you collect? Then give to me after class. Okay. It will be useful for your attendance. Okay. So I think all of you guys correct the answer. So yes, 10 out of 10. Okay. I did the same Harvard quiz many times. Sometimes there exists a student who grade 1 out of 10 or 2 out of 10 really. You don't have to do that for this. Okay, so next one. This. Okay, normalization. So, why don't we go back to the beginning of the semester? So first half of the semester, so we learned about what? What was the topic at the beginning?
ER model.
So we have learned about database design. Okay? So how did you design the database? ER model. So we can apply logical modeling, conceptual modeling, high-level modeling, which is not directly related to the computer science. Instead, it can be general idea. Actually, you can use the ER model for your design of your house, design of the idea. So, for example, when you organize your room, probably your room is messed up, right? So I'd like to organize my room. Then you need to group, right? So this is the database file. This is the operating system stuff. Like that, you found the entity, then is there any relationship? Those are the class or whatever. So it can be used for anything, but we adapt the ER modeling for conceptual modeling. Then we learned about what? Relational model. So using that, the ER model, ER diagram, we can convert, map into the relational model by following the rules that we have learned in the relational model, like the relation. Okay, primary key entity, foreign key entity, something, the constraint. So by following such a rule, so we can convert the ER model to the relational model. Then finally, we can create the table, we can create the index, we can insert the data by following the SQL, by using SQL, the structured query language. Anyway, the relational database model, relational database system is computer stuff. They can understand what I ask. Okay? Unlike the student or human being, they can understand what I'm saying, but the computer cannot understand what I ask. Instead, we can use the computer language. That is a SQL. Using SQL, we can create the table, we can select the data, and so on. That is the database design. There is another way to design the database system, to discuss about such a thing. So there's one thing. There's one thing that most of all database developer, database designer, database administrator really hate this one thing in database stuff. Can you imagine what is that? When they manage the data, they really hate this kind of data. Duplication, right? It's too early to answer. I need to play with you guys. So duplication, why? Why database? Guys, they really hate the duplicate data or redundant information. Sometimes it's called the redundant information. Why? It's a cost. Sometimes it costs a lot to manage the data if they are redundant. For example, so UB would like to manage the student information, including address. So payroll office has the student information, including address, and department has the student information, including address. Also, student center has the same information. What if I move to new house? You need to inform this one, this one, this one. You don't know where they exist. It takes a long time. Even you do not know. So in terms of a database administrator, it's very hard to manage such a data because they exist redundant information. Database stuff is the same thing. Relational database model is the same thing. Think about what is the first constraint in the relational database model. Key, primary key. There exists one primary key in each table. What is a primary key? Non-null and unique. It does not allow any duplicate data. That's a very strong rule. That's a very strong constraint. Because of that, it's not easy sometimes to create the relational database. However, because of that, it's easy to manage. Okay? Because using the primary key, we can access very quickly such a data. So it's kind of the database stuff is finding such a redundant information and the duplicate data. So there is another way to design, to create the database model database design that is using the normalization. Is there anyone who heard about the normalization process in database? What is that, normalization?
We have to specify the table, like department and employee. Then we, if we didn't normalize the table, then all the information should in the one table. And if we normalize the table, then we split
Yes.
into the employee.
That is the formal definition of the normalization. Why don't we go back to the elementary math or the middle school, high school math? When you learned about thank you so much your answer, but we'd like to simplify the problem. That is have you ever heard about so this data should be normalized, right? What does that mean, normalized? Normal means normal. It's not special. Normal means in general. In other words, it should have the same scale, right? So he got the 10 point out of 10. He got the 20 point out of 100. Which one is better? His score is definitely better. But absolute value, he's better because data is not normalized. So we can normalize it to what? 0 to 1 scale, he's the 10, and his score is the 0.2. Then he's better. So that is the normalization. Also, we can normalize the distribution in the statistics. Can you remember the normal distribution that you learned in your math class?
Yeah.
So what is the normal distribution? Yes, like that. So like this. This is the normal distribution. So normal distribution means actually from the Gaussian distribution. What is a Gaussian distribution? Gaussian distribution, there are a bunch of other distribution in the statistics. Then what is a distribution? It's a distributed of the data. In the statistics, what is the main goal of the statistics? Did you learn the statistics? Yes, when I checked, I have the 10 years experience to teach the master or the graduate level PhD student. Many of them are from the non-US country. I checked each and every educational system, especially math, all of the students learn about the statistics. Right? Except some of the students from United States who fail. So some of the level. But what is the distribution? What is the statistics, by the way? It's too difficult? Too much philosophy? Statistics, we'd like to see some characteristic of the data. Okay? But it's not easy to understand. So for example, the demographic information in Connecticut. Do I need to check all of that? No, it's not easy. Also, even though I have all information about the residents in Connecticut, so how many of them? 2 million, 3 million? I'm not sure. So I have all of them. So can I understand the characteristic of the Connecticut? It's not easy. Some of them possible, but sometimes not. So when I quickly look at this one, distribution of the data, so not easy. So to understand the characteristic of the data quickly, we can actually reorganize. We try to see like what is the average, what is the maximum, what is the median. Then we can quickly understand. For example, the median income is the 100,000 in Connecticut per household, which is better than the Texas. Texas, I'm not sure, but anyway, so it's better. So we can say the quality in Connecticut is better than other states, something like that. Okay, then we can using what? Such a statistics. So one of the way to represent the characteristic of the data is like why don't we use such a distribution? Like this is the income level from 0 to the 1 million. Okay, we can line up by the income. Then we can see such a something distribution. In this case, we can make the model of such a distribution. One of them is a Gaussian. Gaussian can be this one. Actually, if we line up such a data, it's not like the exactly curve. It's just something, sometimes up and down. It's just some detailed data, not exactly this. But we make the smooth and make the curve. Sometimes it form a Gaussian distribution which can be represented by only two values. So distribution means using parameter value you can represent such a curve. Parameter means in case of Gaussian you need
Standard deviation.
mean and variance. Using two values. Mean value is the average. Variance means how much far from the mean value. Sometimes wide, sometimes narrow. So I showed the maximum, minimum, average, standard deviation. Standard deviation is the square root of the variance, right? So usually we can say square. So using two parameter value, we can see all the data easily. I don't have to see all each and every the score, midterm score. By showing the average and the variance, you can understand where am I and how much far from the A or B or C or D, something like that. That is the Gaussian distribution. Normal distribution means it's the same as the Gaussian, but we normalize by average. We can adjust the distribution to the mean value into 0. Normalize. That's the normal distribution. Similarly, in the database design, normalization means, so in case we have, so our goal of the database design is, sometimes we can say, remove any redundancy. Remove the duplicate data. That's our goal. If we can remove such a redundant information, that's easy to manage the data. So such a remove the redundant information is called normalization. We try to normalize data. So unnormalized data means we can collect all the information. If you are asked to design the UV database system, you collect all the information. You have a big bucket, then this is the information, this is the information, and you can get the temperature, you can get the size of the room, and how many chairs, or any information you can put into one bucket. That's the information. There might be duplicate data inside this bucket, right? Because it just put all the information. It has your address, it has something. So there are many. So we try to normalize this big bucket. That's called the. So, for example, we separate by the employee information, student information. Even employee information we can set. So this process is called the normalization. In other words, we try to remove any duplicate data. In other words, we can remove any dependency. Because duplication means they depend on each other. So that is called the normalization process. So we can use such a normalization process to design the database design. For example, we put all the information and normalize. So when we apply the normalization process, there are different steps. From first step, normalization form. Second, normalization form. Third, normalization form. Fourth, fifth, and so on. And sometimes the both code B and C, the normalization form. So we will see step by step, okay, such a normalization. Nowadays, practically we do not use the normalization form only for design. Instead, first we can apply, so because it's very hard. So like if you design the US government, too much information. So if you put all the information in one bucket, it's very hard to find which one is normalized, which one is not, which one is related. So instead, we are going to apply the ER modeling step. Logical and logical conceptual design, and apply the physical level design. After that, we consider, after we have the initial database design, we use the normalization process for enhancement. is there any, sometimes you realize there is redundant information after you follow it. Okay, so we try to apply this one after the database design we have it on. Okay, then there are two ways of the normalization. One is informal way. Another one is a formal way. Informal way means what? Non-mathematical approach. I'm going to just describe. We need this table, we need this table. It's based on the guideline. So we are going to discuss several guidelines first. Then the formal way of normalization means mathematical way. At that time, we will use, what is this? In your algebra course, algebra 1, algebra 2, you learned about the function. What is the function? X to 1. X is a set, another set. Using function, you can change the value. It can be used for dependency. In case of X, it will be 1. It's a dependency. So we will use a function to discuss about the functional dependency. That is a formal way of normalization in the next class. So I'm thinking a little bit change of the last of the semester schedule. It will be a little bit delayed to focus more in this. And probably omit the half of the chapter which is not relatively, which is important but not relatively important. So the next class we will talk about this, then followed by I will let you know the next week the schedule. Okay, any other question? Okay, see you next week. Our next class.